Okay, so welcome to my talk. It's called Make Better Decisions, Experiment, and it's going to be about A/B testing, experimentation, and how the culture of experimentation can help you keep your apps healthier, and just like why it's a good idea to do A/B testing, basically. So we're going to go over the what, why, and how of experimentation, anything app-specific, and then a little bit into some statistical gotchas. Stats are hard, but we're going to go over like some basics and stuff. And then, the example that gets tossed around a lot for A/B testing is changing the color of a button. So I'm going to go over some examples of what's beyond changing the button color that you can do with A/B testing. So, hi, I'm Kate. I'm an Android engineer at Etsy. And before Etsy, I worked on a lot of like waterfall style projects. So you get designs, you build it, you'd ship it, but like all the decision making was done at the very beginning, just once at the start. And there was like no way of knowing whether the users of these various apps that I was working on were getting the best experience, because like the client would get their app, they'd pay me, and they'd go away. But here at Etsy, I'm working on something that's getting like constantly tweaked, but like with confidence, and the app is constantly getting upgraded with like measurable impacts. So how do we enable that? Experimentation. So what is experimentation, and why am I talking about that instead of A/B testing? It is slightly different, like yes and no. A/B testing is a way to split the experience and compare it, but experimentation as a whole is a larger concept. So much like a scientific experiment, you start with a hypothesis, which is like an educated guess about, what your changes will affect. Like, are we measuring something? Is it going to change before and after? And then once you have a hypothesis, you use A/B testing to prove or disprove your hypothesis, or A/B/C testing, etc. And we'll get into that too. So let's start by defining a couple things off the bat. The control is the baseline, which is like what your users see today. The variant is the change thing that you want to see if it affects anything. And the hypothesis, again, is an educated guess. So next up, why run experiments? And to get into this, we're going to go with a little story about infinite scroll. This is a real thing that happened at Etsy years before me, but we reference it a lot, and it's become part of our culture of experimentation. So let's say you have like a search functionality, and the results come back to the user in pages. And there's a row of buttons at the bottom of the screen. They have to click each time they want to go to the next page. So, all right, users have to click. That's fine, probably. But infinite scroll, like this is great. Obviously, infinite scroll is better, right? Not quite, but why? So let's get into it. So you're really excited about building infinite scroll. You solve some cool technical challenges. You're like really jazzed about it. You spend a lot of time on this feature. And then you decide that, okay, we're going to ship it, but let's test it. Let's just see, like, we want to brag to people about how much better infinite scroll is. But it turns out, like, it's a good thing that you did A/B test it, because when the metrics come back, there's fewer items viewed, fewer things were purchased from infinite scroll search, and fewer people were favoriting things. So, like, what happened? Whoop. My audio cut out. You're all good? All right. Flying blind. So what happened? There must be bugs, right? And other things we tell ourselves, when the sunk cost fallacy kicks in. So, okay, sure, like maybe there were a handful of bugs on Internet Explorer, but Chrome users had the same, dip in metrics. So let's back up a little bit. What exactly happened? What part of infinite scroll made the experience worse? And why did we expect it to be better? And that's the key thing here we're going to dig into. So if we had written some hypotheses beforehand about why infinite scroll was better, maybe we could have caught this. So is it that there are more items in search results with infinite scroll? Is it that it's faster to view more search results? So let's see if we can break these down into simple tests that don't require writing a huge feature. So more search results viewable at once. Is it better? Maybe. So originally we had 40 items per page. Let's try 80 items per page. And there was no change. So that's odd. What was our other hypothesis? It's faster to load more search results. You don't have to click a button. All right, so in this case, we'll try the control being, the same search speed we have today, and the variant, instead of doing a bunch of work to increase the speed of search results, we'll just slow the variant down. So in this case, we would want to see the control be better. But there was still no real change. So if we'd done these simple experiments before writing this brand new feature, we could have saved some work and not had to feel bad about throwing it away. Because both of the hypotheses were disproven with these simple tests. So how can you avoid that bad feeling of having to throw away something that you worked on? Well, you have a culture of experimentation. You can run short tests of the underlying assumptions about hypotheses before doing heavy dev work. So how exactly do you run them now that we know why? First, you need a way to split traffic. So differentiate half your users from another half. But it's also important that it's not the same users every time getting A and B, because you don't want that. That's going to be bad for the stats. Your data analyst will yell at you. So don't just assign based on whether the user ID is odd or even. Luckily, this is a solved problem. There are plenty of third-party tools. Optimizely, Firebase, I heard Bugsnag is coming out with one, and that's going to help you bucket or split up users. So now that you have your bucketing or splitting set up, you implement the variant in your app. So this is where you do that small bit of dev work. And toggling a Boolean turns the variant on or off. And whether or not you have a cool in-app preferences panel to do this is optional, but it's nice to save some build time if you just want to toggle it really quickly. So finally, you hook up that Boolean to your traffic splitting system so that A is off and B is on, and voila, you now have half your users seeing something different. But you also have to make sure that you're recording the data from both A and B. Ideally, your traffic splitting system will also tie into your metrics collection so that you can actually distinguish a behavior difference between the two cohorts, where cohort is the users in a particular bucket, and bucket is the split of traffic receiving A or B, the controller variant. All right, so let's distribute your app, get that new experience out to users. But also, one quick gotcha, make sure that you default to the control, just in case your traffic splitter isn't reachable or something, or the service goes down. This isn't so much a problem for web, because apps can be launched offline. Just make sure that you're not accidentally showing the variant while offline, because that could lead to some weird stats. So let's look at some other app-specific tips. On the web, you can deploy changes instantly or with a big scary button like Squarespace here. But with apps, you have to go through a process. If you have a change, you have to build it, put it in the App Store, and maybe wait for review. So it's more difficult to turn things on and off. So how does the culture of experimentation have to change because of this delay? Well, if you have a bug in the original launch and you have to turn it off, you have to wait until the next release of your app to fix the bug and then turn the experiment back on. But you also have to discard that old data because you don't want that contaminating your results. Likewise, if your app user base and your web user base are very different sizes and you're running a similar experiment on both, you could see your hypothesis proven very quickly on web because you have way more users, whereas it might take more time to run on the apps. But you can't just assume that because it works on web, it works on the apps. And same thing with Android and iOS. Even if you're running an apps-only experiment, it could be great on iOS and poor on Android, or vice versa. And that's something where you'll have to make a decision whether you want to just power through and use the same experience for both, or if it's a big enough difference in the metrics, or if you have enough employees to maintain a difference across platforms, because you do want your users to have the best experience. Maybe if you're just starting out, then maybe it's more important for you as a team to have the same, but ideally, Android users should be able to have their own unique experience. So if you're wondering before, oh, but there is a way to turn off stuff in apps. Yes, feature flags. This is a thing. You get it for free with experimentation because the way that A/B testing works, you have to like name your experiment something, and you can just as easily name that a feature flag, and then instead of having A and B being 50%, you can slowly ramp it up or turn it off if there's a bug in the release. So I guarantee you the first time this happens with like something you worked on, you're just like, oh, it's crashing, but boop, no more crashes. You can feel a little bit more like web and have that instant feedback. It's pretty nice. And it is a really low effort to put things behind flags. So one more thing, you shouldn't make sure you're bucketing your users too early. So you should be splitting them into the control invariant, like on app launch, for example, because what if you're testing a change to like the favorite screen, but you have a user who like never clicks on that anyway? You don't want to assign the changed version to someone who won't even tap on it. So ideally, you bucket the user or split that traffic right before the user would see a feature. If you don't do this, you get something called bucketing skew, which might be like an Etsy specific term, but it just means that when the percent of users that see your control invariant isn't 50-50, math gets mad at you, the data analysts get mad at you, don't do it. It can lead to some like weird statistics, and it might even like disprove your hypothesis, but it might not be like a real effect. So what other statistical gotchas are common with experimentation? There's a lot of like special stats vocab and some maybe like counterintuitive lines of thought. It's totally okay if you don't understand them. I don't expect to be able to teach you in like 10 minutes. Ask a data analyst. But I was able to learn a little bit while writing this talk, so hopefully that will come through. I found some ways that they finally clicked for me. So real quick, we have A/B testing versus ABC, etc. testing. If it takes, for example, like 2 weeks to gain significance, which is like to be distinguishable from random fluctuations, for an A/B test that is like 50 and 50% of traffic, then it'll take even longer for an ABC test. The smaller split means fewer users per bucket, and it's more difficult to differentiate it from just random noise because your population is smaller. So like if it's 2 weeks for an A/B test, it's not just 3 weeks for an ABC test. It could take even longer because the differences are going to be larger. Okay, the two main vocab words here, significance level. So what percentage of time are we willing to be fooled into seeing an effect by random chance? I had to read this like a few times to really get it, but I think I finally got it. So like the longer you run an experiment, the easier it is to differentiate from random noise. So usually people say like 5% for this. And then the other one is power, which is what percent of the time are we willing to miss a real effect. So for example, if you change the color of a button and you're like, this is better, this should be great, and the metrics are neutral, it's still possible that it's better. And generally this is like 20% of the time we're willing to miss a real effect. So the numbers that get used are like 5% for significance level, and for power it's actually like 100 minus the number, so they say it's 80% power. Even though it's like 20% of the time, we're okay missing it. So let's look at a story about looking at data too early, or like the statistical gotcha of I've been running the experiment and I'm looking at it and it looks good, so let's turn it off. You really do want to wait until the data analyst says it's okay, or you've collected that predetermined amount of data. But why? So let's say you have like a UI refresh of your like purchase list page, and your hypothesis is that reviews will increase because the review button now looks clickable. So, it's like a little quick. You worked on it. It's been running for 1 day. It's out in the wild. But you're like really excited to see how it's doing because like obviously there must be like a quick change. So you peek at the results. And the data analyst like sensed this, and she's like running over. She's like, no, don't do it. The results are down. But this doesn't make sense to you. Like you start questioning everything. Like, are there bugs in the implementation? And finally the data analyst shows up and she's like, no, like you're too early. Stop. This is why it matters. And then she'll say something like this, and you'll have to read it like 6 times. But the amount of data matters because if you have like So you can stop an experiment if like the p-value goes below your significance level, which just means that like you have enough data that it is statistically significant. But if you check like 500 times, even if your control and variant are the exact same, due to math, if you keep checking and stop an experiment as soon as the p-value goes below the significance level, then there's a 50% chance that you could accept that different outcomes occur, even if the control and variant are exactly the same. I still actually don't get it a little bit. So I read this whole thing like 6 times. Okay, the false positive of each test, so like you look, is it done, is it done, is it done, that will compound and it will increase the overall probability that you'll see a false result. So TLDR, just don't peek. The data analyst tells you to. We have a really helpful UI for experiment tracking. It lets you know when results aren't really ready. So you might see like that, this third one here, like metric isn't powered, not ready. So you can look at it, but it tells you a little bit more forcefully like, hey, this really isn't ready. Don't make any decisions based on this data yet. But it will allow you to check in on something and see like, oh, if it's crashing or if it's like really tanking something, maybe just turn it off. But you know, if it's just like a little negative, you probably want to wait until it's fully powered, where power again is like having enough data to make sure that it's statistically significant. So in this reviews are down example, you may see that like the confidence interval, which is that little bar, that green or red or gray bar in there, will be, oh, it's a little bit negative, but also maybe it's 0, like it spans 0. So more data comes in, a few more days, everything starts evening out, and it just turns positive. So after enough data, the metric is powered, and we have a statistically significant result that supports our hypothesis. And we roll it out to 100%. So lastly, I have 2 more examples of things that go beyond changing the color of a button. This is like, I did not think this thing was possible, but the wildest thing I've ever seen A/B tested was the complete navigation of our app. So on Android, we had a hamburger nav menu for a really long time. You know, that was the thing back then. And iOS had a bottom nav, but now we have, oh yeah, material bottom nav. This is great. Let's see about doing this on Android. And the PM was like, okay, but can we A/B test it? Okay, sure. And sitting in the audience here, I worked on this. Thank you, Jordan. Somehow we were able to use both the hamburger nav and the bottom nav in the app at the same time, toggleable with a Boolean, and nothing broke. And you can A/B test anything if you can A/B test that. Like, that's incredible. So we ran this thing for like over a month, 50-50, and because we had moved the favorites screen like out from its place in the hamburger nav into the bottom nav, all of a sudden our users knew it was there, and that was great. We were getting more favorites. So we ramped that up to 100%. And another more recent example of like why the culture of experimentation is good, like obviously, oh yeah, can you A/B test this wild change? Sure. But with this one, we redesigned our cart screen for iOS and Android. And the hypothesis was that, you know, it's more tap friendly, it's like more airy, the images are larger, it looks really, really nice. There's no beige. We got rid of the beige. And on iOS, this was great. And on Android, like, for some reason it wasn't so great, and we were really confused about this because they look and feel the same on Android and iOS. So we, again, just like the infinite scroll example, we looked back at our hypothesis, tried to split it up, and we had increased the image size, but that increased the whole size of the card. So you couldn't easily like maybe compare 2 items in the cart. So we're altering our hypothesis. We're keeping the new design, making the images a little bit smaller. So they're around the same size now. And this is going to run soon. And we're really excited to learn what happens. So hopefully now you recognize when experimentation is a good fit for launching a new feature, or changing an aspect of an existing feature, or altering your hypotheses. And you should be able to give an example about why having a culture of experimentation can help your app stay healthy by making the right decisions. So go forth and hypothesize. Thank you.